Hello students, myself Dr. Rachna Pathak, Assistant Professor in Faculty of Engineering and Technology, University of Lucknow. The topic of today's lecture is Center of Mass, Constant and Variable Densities. In this lecture, we will study how to apply double integration for finding center of mass. So, we goes to the what is mass of lamina. We also as known as center of mass. In Cartesian coordinate, the mass of lamina is given as the product of area and density. In previous lecture, we will study how to find area with the help of double integration. I revise again. What is the double integration? This is double integration dx dy and the limit goes to y1, y2, a to b. The double integration, this is the area of the enclosed curve. If we draw the strip, what is the method for finding this area? We use two methods. Draw the strip parallel to x axis and draw to the strip parallel to the y axis. So, the methods are parallel to the x axis and parallel to the y axis. We use any one of this method parallel to the x axis or parallel to the y axis for finding the area. For finding the mass of lamina, first before study how to find double integration, how to use double integration for finding area, then we find the mass of lamina. What is the area into density? Density may be constant and variable. So, here form the area in the second integration, there is a double integration, dx dy is the form of area and rho is a density. If rho is constant, so we can written as the constant, that means rho is k. K is any constant, the k double integration dx dy. If rho is variable, that means a function of any variable, that is rho is a function of f x y, and put here with integration is double integration f x y dx dy. We can study here in the Cartesian coordinates and we can also write in the polar coordinates. Mass of lamina is product of area and density and the double integration rho r d theta dr. In the previous lecture we study x is equal to r cos theta, y is equal to r sin theta. With the help of Jacobian matrix we can write dx dy equal to r dr d theta. We know the Cartesian coordinate form and we put dx dy is equal to r dr d theta and rho. If rho is constant, that we can written as k r d theta dr, and rho is a function of some variable, that is a function of r and theta. Double integration f r theta r d theta dr. This is the formula for mass of lamina in Cartesian coordinate and polar coordinates. So, we goes to the example based of how to find the mass. Find the mass of the lamina in the form of the ellipse x square upon a square plus y square upon b square if the density at any point varies as the product of the distance from the axis of the ellipse. Okay. First, what say that mass of lamina, what is the ellipse, and second is that density is any point varies the product of distance from the axis of ellipse. The first point here, density is not constant. Density is not constant, it varies to form. According this, we use second formula when density is vary. So, we draw the ellipse. What is the ellipse figure? This is the ellipse, a y axis and x axis, this is the ellipse. Ellipse equation is given at x square upon a square plus y square upon b square is equal to 1. What is the mass? Mass equal to product of area into density. First find the area. Here the equation of curved ellipse and he have 4 coordinates if we find the area of this first coordinate and multiply by 4, we find the whole area of this ellipse. So, first we go the first coordinates, and if we use here double integrations, so we can write here this first coordinate and draw the strip parallel to the y axis and find the limit. If draw the strip parallel to the y axis, we find the limits of y in the function of x. So, here we can say that where the equation is x square upon a square, y square or b square to 1 and find the limit, that means y square upon b square is equal to 1 minus x square upon a square, that means y square is equal to b square, a square minus x square upon a square, and y goes to plus minus b upon a under root a square minus x square, but we take only positive coordinate and the first coordinate. So, y goes to where it is equation, the strip is goes to x axis to this curve. That means this question is y is equal to 0 here, the x axis, the value of y is equal to 0 and the curve is goes to y is equal to b by a under root a square minus x square. So, limit for y is 0 to b upon a under root a square minus x square. What is limit of x? We find at 0 to a, that means because at the ellipse, that is the point is, this is a, this is minus a, is b, this is minus b. Okay. That means a cut in this point is a comma 0, that goes to x where is formed to 0 to a. To put in the equation of the area, we have what is equation is 0 to a and 0 to b by a under root a square minus x square dx dy. This is the equation of area. And now find density. How to find density? It goes to the statement of this question is what say that the density and point varies as the product of distances from the axis of the ellipse. What is the distance? That is the x axis and y. The d is proportional to x and y. That means d density is proportional to x y. We can write as density is equal to k times x and y. So, density is product of k x y and mass is equal to can be written as a into d. So, we put here double integration 0 to a, 0 to b upon a under root a square minus x square and k x y dx dy. This is the equation. We can write, we can see here there is a limit in the function of x. So, we integrate this integration with respect to y firstly. So, we integrate with respect to y, that is the x may be as constant here because we integrate this integration with respect to y square upon 2 0 to b by a under root a square minus x square dx and put the limits. We have 2k 0 to a x b square upon a square minus x square dx. So, here is the function in the form of x only. So, integrate this integration with respect to x and find the required result. So, k b square upon 2 is the required result. So, goes to the second example. Find the mass of a plane in the shape of the curve x by a 2 by 3 plus y upon b 2 by 3 is equal to 1 and density being given by rho is equal to k x y. Here the one question here, how to draw the figure of such like curve, ellipse, circle and parabola. We know how to shape of this curve, but we do not know how the shape of like this curve. We using curve, tracing of curve with the help of tracing of curve we find that asymptotes, tangent, intersection terms. Using the tracing of curve we draw this curve is like this. Using tracing the curve is like, sorry, this like this, and x upon a, y upon b, this curve, this is the y axis and this is the x axis. The curve like this, we use the tracing of the curve and find the interaction terms and find the area. If this you say that this is symmetrical about the x axis, symmetrical upon the y axis, if the find the area of this first coordinate and multiply by 4, we find the whole area of this curve. So, we draw the strip parallel to the y axis and find the limits of the y in the form of x and find the limits of x in the constant form. So, we firstly write the what is the curve? Curve is the area enclosed by, this is the curve A, B, C, D, and interaction terms, using the tracing of curve we find the interaction of terms. If for the x axis if put y is equal to 0, we find the point at a equal to 0. For the x axis for put the x equal to 0, find this interaction terms, and also similar way we can the find of this interaction terms 0 b, minus a to 0, 0 minus b and 0 a, and this is the curve symmetrical about the both axes. So, we for use only this first coordinate and find of area of this coordinate and multiply by 4. So, what is the limit from the is for this y, this we can see here, that is the value of this is just the x axis, here the value of y is 0, and the equation here we have, we use this equation and all values of x and and coefficient to right hand side, and the value of y is equal to b upon a ki power 2 by 3 minus x ki 2 by 3 ki power 3 by 2. So, y varies from 0 to b upon a ki power 2 by 3 minus x ki power 2 by 3, 3 by 2, and x varies from 0 to a. This is the limits from x and y. So, area can be written as, what is the area? Area is can be written as 0 to a, 0 to b by a ki power 2 by 3 minus x ki power 2 by 3, 3 by 2, this is the first coordinate, and we find the whole, we multiply by 4. It is also posed in the previous question, and find the density. What is the density? Density is given rho x y, no, sorry, k x y. K x y is density, d is equal to k x y. So, mass of lamina is m is equal to a multiply by d, a product of area into density. So, put the values, we have 4 times double integration rho dx dy, 4 times what is the value of rho is k x y dy dx dy, put the limits of x and y axis 4k 0 to a kx dx 0 to b upon a ki power 2 by 3 minus x ki power 2 by 3 power 3 by 2 dy dx. Their limits are in the form function of x. So, integrate this integration with respect to y firstly, that means y square by 2, put the limits and we get the function in the function of x. So, integrate the given integration with respect to x, put the limits, we get required result. So, both example we firstly find the area using the double integration, we draw the strip parallel to y axis. If we do not know how to use double integration for finding the area, we can't solve this like such like question. So, first study what is double integration, how to find the double area with the help of double integration, then we solve such like examples. Now, we go the third example of this lecture. This is example third, is to find the mass of the lamina bounded by the curves y square to ax and x square to ay if the density of the lamina at any point varies as the square of its distance from the origin. Here we can see that here the target is mass of lamina, but here given two curves, both curves are parabola. If we know how to find the enclosed area between this curve, we can solve it, otherwise not. here also the density is not constant, is the square of its distance from its origin. Firstly, we goes to the area. Here the equation of parabola is given as y is equal to ax, x equal to ay. So, first find the interaction terms of this parabola. What is this? That is a y is equal to ax, that means put the value of x in both in the first two, that means x, what is x? Y square upon a x square is equal to a y power 4, a square is equal to a y, that means y 4 is equal to a cube y, that we can be written as y 4 minus a cube y is equal to 0, y cube minus a cube is equal to 0, the y is equal to 0 or y cube minus a cube is equal to 0. Solving this equation, we have only real values y 0 or y a. We get y is equal to 0, y is equal to a, corresponding put the value in the second equation, we get what interaction term is 0 comma 0 and a comma a. This is the parabola x square to a and this is the parabola y square to ax, and this is the enclosed area. Find the area of this enclosed curve. So, here we have two methods, draw the strip parallel to y axis or draw the strip parallel to x axis. If we draw the strip parallel to the y axis, the limits of y were function of x, and if draw the strip here in x axis, the values of limits of x in the function of y. So, we can use any one. Here we use only draw the strip parallel to the y axis. So, what is the limits for y? Here we can say that the y is goes to this curve to this curve. The equation of the curve is x square to a y. So, limit is y square to x square upon a, and second is y square to under root a x. So, the limits of y in the function of x is x square upon a under root a x. This is the limits for y. What is the limit of x? We can see from the figure that the limits of x is 0 to a. The limits of x. So, the point of interactions of 1 and 2 is a comma a. The area enclosed by 1 and 2 is 0 O A B C O, and the vertical strip varies from y square to x square a to y square to under root x, and x varies from 0 to a. The next question is what is the density here? The density is the proportional to the square of distance from the origin. How to find the distance? We have the formula is, we know that if we have 2 points, there is a point is origin and the second point is x y. Find the distance between, the equation of distance is x minus 0 whole square plus y minus 0, that means x square plus y square. Density is proportional to what? D square. D square is equal to x square plus y square. So, we can write the density is equal to k times x square plus y square. So, put the value of density and area in the equation. Finding the mass of lamina, double integration k times 0 to a dx, integration x square upon a under root ax, x square plus y square dy. There is a limit in the function of x. So, integrate this integration with respect to y firstly, that means x square y plus y cube by 3, x square upon a to x is the limit, and put in the limits in the equation. We have k times 0 to a x square under root ax plus under root ax cube by 3 minus x square by a minus 1 by 3 x to the power 6 a cube ds. We can see here there is a function of x only. So, integrate with respect to x and put the limits, we get the required result 6 k a to the power 4 35. This is the required result mass of the given curve. The last example of this lecture is find the mass of lamina bounded by the curve. What is the curve? 16 y square x cube and the line 2 y square to x. if the density at a point varies at the square of the distance of the point from the x axis. Here we have also a parabola and the second is line. So, first draw the figure, find the interaction terms and draw the strip and find the area and then density, and the product of density and area find the mass of lamina. So, we goes to the equation here 16y square and x cube, and the second is 2y is equal to x. So, interaction terms is 4 by 4 comma 2. How to find this? We have 2y is equal to x. So, put here 16y square is equal to 8y cube and solve this, that is 2y square is 8 or yeah 2 is equal to y is equal to 2, put the second equation, that is x is equal to 4, that is coordinate is 4 comma 2. This is the 16y square x cube. This is the what is the form of such like curve? We using the tracing of curve. Use the tracing of curve, we find a tangent, find the asymptote, how where which find interaction terms also. If put the y is equal to 0, we find the interaction term x axis. If find y is x is equal to 0, we find the interaction term at x axis. So, we had find the interaction term, there is a 0 0 is origin point for this curve, and this is the tangent which go touch the equation is y axis is tangent of this curve, and the interaction and the line 2 y intersect this curve at 4 comma 2 and find the area of this shaded region. The shaded region is 0 a 0 O is a O. So, if you find the area of this shaded region, we draw the strip parallel to the y axis and find the limit in the function of x. So, here we can see that the strip goes to this touch this parabola to this straight line. The equation of the y is, the equation is what is the parabola, this curve like equation is 16y square is x cube, that is y square is equal to x cube by 16 or y square to x की power 3 by 2 is 4. This is y square to x 3 by 2 by 4, and what is the second is y square to x by 2. If we draw the strip parallel to the x axis, the limit goes to what is? Their limit goes to x axis, limits of x in the function of y. So, x is equal to 2y and second is x is equal to 16y square की power 1 by 3. If we draw the strip parallel to the x axis, the limits in the function of y, function of what? Function of y, and we draw the strip parallel to the y axis, the limits of y is the function of x. In this question, we draw the strip parallel to the y axis. So, we can find the limits. Y is x की power 3 by 2 8 by 4 and y is equal to x by 2. What the limit for x is 0 to 4, and put the values in the equation this. Equation we get equation this, the area is OPAQ, the vertical strip varies from y s की power 3 by 2 by 4 and to y square to x by 2, and x varies from 0 to a. This is a limit from x and y. And density, what is density? Density is proportional to density proportional to distance from the y, that is a y square, density proportional to y square, density to k y square. The area is OPAQ and the vertical strip varies from y s की power 3 by 2 by 4 to y square to x by 2 and x varies from 0 to a. Here from the question we can see that density is proportional to y square. So, density is equal to k y square. How to find the mass of lemma? We know that mass of lemma is the product of area into density. So, put the values of this 0 to 4, 4 by 4, s power 3 by 2, x by 2, dx, dy, and we also write dy and the k y square. This is the value, the limits in the function of x. So, we integrate this integration with respect to y, that is k y cube by 3, put the limits s power 3 by 2, 4, x by 2, and we find putting the limits, and the function is the function of x only. So, integrate this integration with respect to x. So, and put the limit, we get the required result is 8k by 11. So, in this lecture we will study how to find the mass of lamina with the help of double integrations, how to find the area with the help of double integration. If we do know how to find the area with the help of double integration, with the help of draw the strip parallel to x axis and draw the strip parallel to the y axis and find and limit them, and with the if the constant rho is constant, the product rho is outside the integration and integrate the given integration. If rho is the variable form, we put in the integration and solve it. So, we goes to the another example, that is the constant rho is constant. If rho is constant, the same question is can be solved as 1 by 4 s ki power 3 by 2 x by 2 dx dy, and the constant is k, this is outside the integration. So, 0 to 4 1 by 4 s ki power 3 by 2 x by 2 dx dy, and solve this integration. The function of x, we integrate with y, put the value of x in the, we get the function in the form of x, integrate this integration with respect to x and find the required result. So, in this lecture we will study mass of lamina, and the next lecture we will study how to find the mass of cavity.